For velocity, it's a differentiation of the function, the position function. So we can leave the 9 out, and we can differentiate the t over t squared plus 9, which is going to be 1 times by the bottom, minus leave the top alone, differentiate the bottom, we get 2t. Okay, and that gives you 9 times by 9 minus t squared when you do t squared minus 2t squared. Okay, so velocity after 1 second is going to be 9. 9 minus 1. 1 plus 9 squared. This is 10 squared. It's 100, so this is 0.72, right? So that's v at 1. When is the particle at rest? So when is this equal to 0 for part C? So this expression is going to equal to 0 when the numerator is equal to 0. When 9 minus t squared is equal to 0. So when 3 minus t when you factor, and 3 plus t is equal to 0. So in other words, t is equal to plus or minus 3, but we're only talking about when t is positive, so we only pick 3. When is a particle moving in the positive direction? So when is the velocity positive? Well, that's also dependent only on the numerator here, because the denominator is always positive. So as long as this expression is always, if it's positive, the whole thing will be positive, right? The velocity will be positive. So this is, again, if you put in a factor form, when is it positive? It's a parabola, okay, that's going downwards with roots at 3 and 3. So it's clearly positive right here in that region. So when t is between -3 and 3, it's positive. But we're only considering from 0. So when t is from 0 to 3, it's moving in a positive direction. Okay. Okay, so what is the total distance traveled during the first 6 seconds? Okay, so from 0 to 3, right, it's moving in positive. And then from 3 and on, it's moving in a negative direction. So for the total distance, okay, what we have to do is we have to get from the distance, right, from 3 to 0. Okay, we get the magnitude of that. And then we have to do the magnitude of from 6 to 3. Right, we cannot do from 6 all the way to 0 because one value is positive, one value is negative. So we have to separate it, okay, where the exactly at the interval where the velocity is 0. Okay, so let's plug in 3 up here, and we get 27 over 9 plus 9 is 18. 54, right, over 36 plus 9, and then minus 27 over 18, right? Okay. All right, so which one's bigger here? Right? I mean, if this was positive, this will cancel out, but if it was negative, we actually have to evaluate this first because there's an absolute value there. So you actually get minus 0.3. So it's going to be 27 over 18. You can divide top and bottom by 9 to get 3 over 2, which is 1.5. Plus 0.3, so you get 1.8. Okay, 1.8 feet. That's the total distance traveled. Okay. So for F, we need to draw a diagram. Okay, so up to the first 3 seconds. So here's time. 1, 2, 3 seconds. It moves forward and then it rests and then it starts going backwards. Okay. And it continues to go backwards. That's the motion. Okay, so in terms of distance, what we did is we found this distance and then we found the distance this way too. So 3 seconds this way, 3 seconds that way, and we got 1.8. Okay, now acceleration. So acceleration is a differentiation of velocity. So we have to differentiate this right here. Let's leave the 9 out. Differentiate the top, multiply by the bottom. Okay, let's differentiate the bottom now. 2t squared plus 9 times by 2t. And t squared plus 9 to the power of 4. Okay. So 9. We can definitely reduce one of that to give you 3. So you're left with minus 2t t squared plus 9 and a minus 4t if you multiply this and this. Okay. So minus 2t cubed minus 18t 36t plus 4t cubed. Okay. So I think we just collect these two. Let's collect these two. Almost done, right? So 2t cubed and minus 40, 50, 54. Okay, so in here we're gonna plug in 0, right? Not 1. Plug in 1. Acceleration at 1 second. So it's 9 minus 2 minus 54. 1 plus 9, so 10 cubed. Okay, so that's minus 9 times 52 over 1,000. Okay, so it's minus 0.468. Okay, so graph the position, velocity, and acceleration function from 0 to 6. Okay, so here's a graph, the 3 graphs drawn from Desmos. Okay, red is the function, the position function. Green is the velocity, and this is the acceleration. Okay, so looking at this, when is a particle speeding up? So it's speeding up when its velocity is positive and the acceleration is going, it's also positive. So velocity is positive from here to here, right? From 0 to 3 seconds. And acceleration is not positive there. It's negative. So it's not speeding up here. So let's consider now when it's negative, acceleration is also negative. They both have to be negative, so they're actually speeding up in a negative direction. And so after 3 seconds, it is negative, and acceleration is always essentially negative up to this point here. So they're both negative from here to there. Okay, so let's find out what this value is, going back to the decimal file. I got that to be 5.196, and this value here be 3.665. Okay, so this one here is actually the x-intercept, so you can actually solve for 0 here and solve for t, and we'll get 5.196. This one here is actually the intersection between the velocity and acceleration. That's quite a bit of algebra work, so I just looked at the graph, okay, and got these two values. So it is speeding up. Okay, the only value, t value, where it's speeding up is between 3.665 and 5.196.